Everyone, welcome to OpenGeology. We are here discussing about the CIL previous year questions. This is Geology section part 9 and we will see from question 81 to 90. These questions are from the exam of 2017. But before we begin, you can join our CIL Geologist test series. There are 100 plus tests belong to each section like the general awareness, English, reasoning, aptitude, geology and 11 full length tests. So you can download our app and join this. For other exams as well, you can join our test series. Let's begin with the first question. On the interior continental shield areas or the cratons, they are traversed by the ancient orogenic belts. But younger orogenic belts, whatever the younger orogenic belts are, they are different from the ancient orogenic belts. So what is the difference? So the younger ones are the hotter and the thicker crust. Okay. Another question is question 82. The metamorphic facies, which represents a transition zone between diagenesis and metamorphism. So you know the sedimentary rocks, they are formed beneath the earth surface. So if the overburden pressure is not high and the temperature is below 200 degrees Celsius, we term that as a diagenesis. And when it is continuously increasing of more than 200 degrees Celsius and pressure is also increasing, then we call that start of metamorphism. So the facies which is the boundary between diagenesis and metamorphism is your geolite facies. Here is your temperature and here is your pressure. So if we talk about the high temperature facies, it is geolite, hornfels, sanidinite facies. And if we talk about the high pressure facies, the geolite, prehnite, pumpelite, blue schist and eclogite. While the moderate temperature and pressure is your from geolite, then prehnite, pumpelite, green schist, amphibold and granulite. So this is the three different paths which a metamorphic process follows. So here the correct option boundary is your geolite facies. So another question is, pillow basalt attain their distinctive blob-like shapes or the pillow-like shapes as their parent lavas do not travel distance prior to the solidification. So as it reaches the surface, it got solidifies. This is because the parent lavas, they erupt underwater and thus cools very quickly. So lava can occur on the continent like the rhyolitic magma, the rhyolite rock will be produced, and if the mafic lava is produced underwater, then the basalt will be produced and with these type of pillow structures. So different rocks may show a different specific their characteristic kind of structure, like the comatite rock that shows spinifax texture. Okay, so you can read about the specific textures related to that. Like sometimes basalt also shows your columnar type of structure, that is hexagonal blocks. Okay, something like this. So there are hexagonal blocks of basalt can be found. Then you have the mural joints generally found in the granites. So the characteristic is structures or textures you can remember. Another question is, a clay mineral just like the kaolinite, they are product of chemical weathering, but of which minerals? So clay minerals like the kaolinite, it is rich in silica. Okay, so that means if presence of silica, the mineral must be silicate. Okay, like this there are different type of different groups and common clay minerals. So under the kaolinite you have the kaolinite Al2Si2O5OH. It belongs to the triclinic system and along with their habits. So different clay minerals like the montmorillonite, it is also the silica. Vermiculite, again silica. Illite, gluconite, all of these are the silicates. Okay, so the parent mineral must be the silicate, so that silica is present in them. Okay, then let's go to our next question. Which of the following is not a result of contact metamorphism? So different type of metamorphism like we have discussed in the second question, geolite, hornfels facies. Here you have the eclogite and blue schist facies. you have the greenschist, amphibolite and granulite facies. So contact metamorphism will follow the high temperature path, and the produced rocks is not the orogenic. All others like the hornfels are there. Spotted slates is a product of contact metamorphism. Skarn deposits or the skarn rocks are also part of the contact metamorphisms. Okay, mostly contact metamorphism do not show you the foliations. Okay, so the lack of foliation can be one of the indicator of contact metamorphism. Then another question is, where do volcanic clusters occurs? Volcanic clusters means the more volcanoes in the same area. So there are two examples: continental lithosphere cluster, where two plates are coming to each other and a series of volcanoes will be formed. So we call that a volcanic arc. So a lot of volcanoes will be found within a zone, as well as in the oceanic lithosphere cluster, where the two plates are going away from each other. We found a lot of volcanoes. So it can be found both on the continental as well as on the lithosphere plate. So second option will be our correct answer. Again, what you can learn related to this question about the three kinds of plate boundaries. Another question is, in hydrostatic state of stress. So there are different kinds of stress, like the simple shear stress, tensile stress, compressive stress, and the hydrostatic stress. So in the case of hydrostatic stress, all of the three directions are equal. Sigma 1 equal to sigma 2 and sigma 2 equal to sigma 3, and they are non-zero. Okay, so we call that as a hydrostatic state of stress. Another question is, the ground motion which is generated by the Richter magnitude scale of 6, it is a factor of how many times larger than the third earthquake. So by increasing in the one magnitude, the ground motion will be 10 times larger. So here it is increasing by 3, so it will be increased by the 1000 times. Correct option will be your third option. Now what else you can remember? You can remember the different scales, like the Richter scale, the modified Mercalli scale. Okay, so the different scales, which scale measures intensity, which scale measures the ground motion, which scale measures the destruction of ground. So all of the scales you can remember. Okay, now another question is, according to Milankovitch cycle, the eccentricity of the Earth's orbit varies over a cycle of how many years? So according to Milankovitch cycle, there are three changes. First one is the eccentricity. You can say first one or anyone. So eccentricity means Earth is not orbiting around the Sun in a perfect circular manner. So rather it is an ellipse. So sometimes it is away from the Sun, and at some point the distance is less. So this particular orbit is continuously changing. It is changing from circular to elliptical, and their rate of change, the complete change, will happen in 1 lakh years. So we call it the eccentricity. Then there is obliquity. That means the current axial tilt is your 23.5. Okay. Now this is also changing from between the 0 degree and 23.5. So it is changing from 0 to 23. Again it will come back to 1, and their time period is 41,000 years. So it will take 41,000 years. Then there is precision cycle. Precision cycle means, although it is let's say this is your vertical line and this is the angle 23.5. So this is also rotating along with the geographical north. So this rotation also takes time of 26,000 years. So within the Milankovitch cycle, there are three different parts, or the three different cycles: precision, obliquity, and eccentricity. And all of these leads to change in the climatic conditions of over the earth. So they will produce somewhere increase in the sunlight, decrease in the sunlight. So all of these three are the part of you can say climate change. Okay, so here the correct option will be your 1 lakh, that is belongs to eccentricity. Now last question is a body of sediment whose surface from the approximate to the segment of a cone which radiates downslope from a point on a mountain front. Let's say this is a mountain front and here is a cone type of a structure. So what we call that? It is a alluvial fan. So whatever river, stream, water it is coming, it is carrying the sediments, and as it reaches to the ground, it will deposit all of these things as a form of a cone, and we call that as alluvial fan. First option will be our right answer. Other things you can learn about the river traces, crevasses, and what are the different bajaras. So it's all about for today. We'll see you in the next part. Till then, you can join our CIL Geologist test series. So 100 plus tests from to each section. It will boost your confidence as well as your performance in the exam. Thank you.